Alright, on 8.3, we're talking about similar polygons. Since this is 8.3, tomorrow we're going to take a quiz.
Why don't you just live stream?
Okay, so you guys are aware for that. Okay, quiz tomorrow. When you have similar polygons. Okay, so if these two polygons are similar, which they kind of look like they are, right? And what does it mean to be similar? Are the sides the same length? No. Could they be? Maybe. If they're congruent, they're also similar. But they're not the same length, but they're proportional. Okay, we've been working with proportions. So we're using more of that. Now, let's go ahead and give these figures some letters here. A, B, C, D, E, F, G, H. Okay? They might do one of a few things. Now, if these angles are congruent, that's one sign that these figures might be similar. Okay? If your figures are similar, then your angles are congruent, your corresponding angles. Okay, so A is congruent to E, which I don't have. B is congruent to F, C is congruent to G, and D is congruent to H. Okay, that's always going to be true if they're similar. Now, if the angles are congruent, that doesn't mean that the figures have to be similar. Okay, over here in my rectangle, I have right angles in all my angles, right? So are my corresponding angles congruent?
Yes.
Yeah, but are those two shapes similar? No, those two shapes aren't anywhere close to being similar. Okay, so just make sure if they are similar, your angles are going to be congruent. If your angles are congruent, they might be similar. They don't have to be though. Okay, does that make sense, everybody? And now there's a few things they're going to start asking you for. So I'm going to tell you that these are similar. Okay. So we want to write what we call a similarity statement. Basically saying that these two shapes are similar. Well, Kobe, how do I name this shape?
ABCD.
ABCD. Okay, that is similar. There's a new sign for you guys. Kind of like the congruent sign, but now it's similar to EF, G, H. Does the order of these letters matter?
Yes.
Yes, it does. Okay, because angle A needs to line up with E, B needs to line up with F, C needs to line up with G, and D needs to line up with H. So your order does matter here. Okay, so that's one thing they might ask you for is, what was this called? Similarity statement. Basically, you're just stating that two things are similar. Another thing they might ask you for is they might ask you to state or list all the congruent angles. Well, angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. Okay, is that it? Yeah. Okay, so there we just listed our angles out, what was congruent. Similarity statement, this is just listing or telling what angles are congruent. Okay, then the third thing that you might have to pay attention for is what they call a statement of proportionality. Now I already told you that these sides are going to be proportional, right? Okay, what can I compare AB to? EF. So I'm going to say AB to EF. Okay, that's just a ratio, right? So to be a proportion, I have to have two of them, at least two, in an equal sign, right? Okay, so AB is equal to EF, or AB to EF is equal to BC to what? FG, which is also equal to CD to GH. And my last one is DA to HE here. Okay. This is called your statement of proportionality. We're showing all the different proportions that we could set up. Is AB to EF the same as CD to GH?
Yes.
Even though they're not side by side? Yeah, isn't that transitive property anyways? Okay, what about to DA to EH? Yeah, this is also equal to this. Okay, so basically it's saying that no matter what side you use, your ratio should be the same, correct? And that's going to work out every single time. Don't tell my wife that I didn't have this underneath the computer when I was filming. I'll be in trouble.
Well, now it's on YouTube.
Yeah, she doesn't. You think she's gonna go watch this video?
She might.
I'm gonna guess. I'm gonna guess no.
I'll tell you.
Okay. All right. So we doing all right so far?
How many people are gonna watch this video?
The next two periods, 6 and 8
So 2
periods.
views.
Oh, so you don't have to talk. So
Shout out?
you don't have to
I'm gonna be gone.
talk.
Hey, can I make a shout out?
No.
Shout out to all my fans.
Hey, at the end of the video,
Guys,
you should have
guys.
us all in front. No?
You wonder why I usually don't video your class.
Oh,
This would be awesome.
Okay. Looking at example 2. Okay. And I have XYZW. And I have QRSP. And I have 6, 9, 12, 15. And 4, 6, 8, 10. Okay. I'm not going to mark the angles that they marked in there, but since they marked that the angles were congruent, there's a chance that they might be similar figures, right? Before, you can't just look at the angles though. Okay, the angles are a hint, okay, but before you can actually say it, you have to show that your ratios are congruent. Okay, so what's one ratio I can set up here? Make sure we're comparing corresponding sides. 6 to 4. So you did XY to QR, right? We did XY to QR, which was 6 to 4, which reduces to 3 to 2. Good. Okay. Do another one for me, Brody.
8 to 10. No. They have to be the same.
Corresponding sides.
Oh, 10 to
10 to 15. I'm going to do 15 to 10 only because Mitch went from big to small. Okay, so we're doing XW to QP. That's 15 to 10, which reduces to 3 to 2. Okay, give me another one, Carissa. WZ to PS, which is 12 to 8, which reduces to
3, 2, 4, 2.
3 to 2. And the last one is YZ to RS, which is 9 to 6, which reduces to
Guessing 3 to 2.
3 to 2. So notice,
They're all 3 to 2.
they are all the same. So, Are these two figures similar to each other? Yes, they are. If they're similar, this will always happen. Okay, so keep that in mind. That will always happen. Denham, can you tell me the let's go with the similarity statement. It's a similarity statement here.
So that would be WZYX
WZYX
is similar to PSRQ.
is similar to PSRQ. Notice he made sure to go in the same order. He went from WZYX, started the same place. A PSRQ. Make sure you have everything in the correct order, because your order does matter. Okay. All right. Flipping over to 474 now. Okay. Talking a little bit about a scale factor. A ratio is just a scale factor. Okay, so when they talk about scale factor, don't get confused. Hey, it's just a ratio, is all it is. Okay, so what we have here is we have a photo that looks like this. It's 3.5 inches by 5 inches. We want to blow it up into a poster. Okay, and I want that poster, I want the base of it to be 16 inches. I gotta have to figure out what's that side length. Okay. Now, what can I do to solve for that side length here? Set up a proportion. Set one up for me, Sean. 3.5 over 16 equals 5 over x. Good. Would anybody else have set it up differently? There's about 4 ways you could set this up. Could I have done?
You could have switched. You could have switched both of them.
Could I have done this?
Yes.
Yeah, I could have. Equals 16 over x. Notice, even if I do it this way, I'm still multiplying 16 and 5, right?
Yeah,
And 3.5 and x.
and we had that thing you told us about, so we could switch them.
Right, we had that property. Good. Okay, so no matter what, either one of these is going to come out to the same answer, right? Just keep that in mind. If you're talking with each other, helping each other out, hey, and you have it set up differently, does that mean one of you's wrong? No. Okay, there's about 4 different ways you could set it up. We could also flip these. Okay, and that would be fine. Okay, so just keep that in mind. Now when I cross multiply here, what's 5 times 16? It's 80 equals 3.5x. Could I have switched these? Yeah, it doesn't matter what side of the equal sign it's on. What does x equal? Now, don't do that with a decimal.
3.5.
Don't leave a decimal in there. This is 3.5 right here. What's 80 divided by 3.5? If I started with a decimal, can I end with a decimal?
Yes.
Yeah, that's okay.
How do you want me to round it?
Nearest 10.
22, 29.
What's my label?
Inches.
Inches. Good. Okay, so my length over here is 22.9 inches. Remember, if you start with a decimal, you can end with a decimal. That's okay. Questions so far? I don't think the lesson's too crazy hard. You just got to be careful with some of the wording. Okay, let's take a look at a swimming pool problem. And we have a swimming pool here. And it has a walkway around it. I think they call it a patio. Okay, so this is all water here. Okay, there's your water. And I have 32 feet by 16 feet.
Looks like a Pop-Tart.
That does kind of look like a Pop-Tart, actually. And I have 48 feet by 24 feet. Okay. Then they ask us a couple questions here. They say, calculate the scale factor of the patio to the pool. Okay. Now, first of all, if I'm going patio to pool, what needs to come first? The bigger numbers, the patio numbers. So, does it matter if I do 48 to 32 or 24 to 16?
No.
It shouldn't. Not if they're similar. Which one do we want to do? What?
48 to 32.
48 to 32. What can I take out of both of those?
16.
An 8. I heard an 8. What's this change to? 6. 4. 3 to 2. Okay, so I have 3 to 2. Now, the next question says, find the ratio of their perimeters. Well, first of all, how do I find the perimeter of something? Add up all the sides. Okay, what's this side length, Brett?
32.
And this one?
16.
So what's 32 and 32? 64 and 16.
38. 32.
Oh, you were doing 16 and
Yeah.
16? It's 32. So what is 64 and 32?
Mitchell, you got it?
Huh?
It's 96.
Yeah.
96.
Yes.
He always does it in his
He
head.
does.
Okay, so stay with me. So the perimeter of the pool is 96 feet. Okay. We also need to find the perimeter of the patio. Okay. Well, 48 and 48 is
96.
96. 24 and 24 is 48. 48 and 96, 144. Okay, so the perimeter of the patio is 144 feet. Now, since we did patio to pool, do you want to do pool to patio or patio to pool?
Probably patio.
Probably patio to pool to make sure they line up correctly, right? So I have 144 over 96. What can I take out of both of those? A 12. So this changes to 12 and 8. Take out a 4. 3 to 2. So what do you notice about the ratio of
They're the same.
the perimeters and the ratio of their corresponding sides? They're the same. Okay. That takes us to our next theorem.
Oh, dang.
A theorem, yes. Okay, it is called similar polygons.
Can I have another?
Sure. Get your pink one.
Huh?
I need to see your pink one. Got it. Okay, our similar polygons theorem says if two polygons are similar, sure, you can use a similar symbol. If two polygons are similar, and the ratio of their perimeters is equal to the ratio of their corresponding sides. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. So, with that information, let's try one more problem here. if I tell you from the get-go that these two figures are similar, okay, first of all, do I have enough information to figure out what the actual perimeter of this is? Or the other one over there? No. But, Daniel, can I figure out what the ratio of their perimeters is? It's the same as the ratio of the corresponding sides, right? So can you figure out a ratio of the corresponding sides?
Yeah.
What is it? Compare two sides.
Would be Z over 6.
No. Be careful. Just one ratio of corresponding sides. So use the ones that you know already.
10 over 15.
Corresponding
I
sides.
don't know what you're saying.
Those aren't corresponding
Corresponding
sides. Corresponding sides.
15 over 6.
There you go. Because they're corresponding, right?
Then you do 10 over
They're in
Z.
the same position. That's if I was solving for Z. I'm not there yet. Okay? One step ahead of me. So I just want to compare my corresponding sides. If I do that, if I do 15 over 6, what's that reduce to? 5 over 2. So what is the ratio of my perimeters? 5 to 2. Okay, so what I'm getting at here is you don't have to have all the information for your perimeter. If you have two corresponding sides, okay, and you know you can find the ratio of them, then that's also the ratio of your perimeters. Okay, so they might ask you a question like this on your homework where they want the ratio of the perimeters, but they don't give you the perimeter. Well, if you know two corresponding sides, you can find that ratio. Does that make sense to everybody? That's not actually in the example. The example wants to know, how do I solve for Z? Daniel already told me 10 over Z equals, or did you say 10 over 15? What did you say? 15. I thought 10 over 15 equals
Z over 6.
Z over 6, good. Okay, can I reduce 10 over 15 before I start doing anything?
Yes. Or 2, yeah, 2 over
2 to 3. When I cross multiply, I get
3.
3Z equals 12, Z equals 4. Okay, now,
Oh, yeah.
again, be careful. Make sure things have a relationship. Could I have done 10 over Z equals 15 over 6?
Yes.
Yes, because 10 and Z are corresponding sides. 15 and 6 corresponding sides. Okay, could I
do
have
it that way?
Could I have done 10 over 6 equals 15 over Z? Could I compare 10 and 6 and 15 and Z? No. Okay, make sure your stuff has something in common. I can put 10 over 15 because what do they have in common? They're on the same shape. I can put 6 over Z or Z over 6 because they're on the same shape. Okay, can I put 10 over Z? Yeah, because they're corresponding sides. Can I put 15 over 6? Yeah, corresponding sides. Can I put 10 over 6? No, they have nothing in common. They're not on the same shape, and they're not corresponding sides. So just be careful. Make sure when you're comparing things in a ratio that it makes sense. They have some sort of relationship. Okay? Questions on those notes? All right, on page 476. We need to do 8 through 38 evens and 39 through 42 off. Okay. Also, there is a what tomorrow?
Quiz.
A quiz. So I would suggest doing quiz 1 on page 479. If you can do this, then you'll be fine on your quiz.